Okay, the first two questions on the 5.1, 5.2 review ask you about material in 5.1. So remember, 5.1 is mid-segment theorem. So go back and look at the notes if you do not remember the details of 5.1. So let's see what question 1 has to offer to us. Okay, the question says, in ACE, so ACE is the bigger triangle. CE, so let's see where CE is. CE is this whole piece right here. So CE is 4x plus 2. And BF is this smaller piece right here. And BF is 3x minus 1. Now I put this question on because this was an often missed type of question on the 5.1 quiz. So what you need to remember is that the smaller piece, BF, if you multiply that by 2, you will then get the bigger piece. These are parallel, and what I know is that BF, so this point right here, right here and here, those are midpoints, so BF is a mid-segment, midpoint segment. So therefore, remember, if you have something like this, if this is a midpoint, and that's the segment, so that's the mid-segment, what happens is the smaller one is half as big as this bigger one. So instead of saying half, say that if I want the big piece, okay, so here's number 2. Number 2 says, in triangle HKM, so HKM is the bigger triangle. J, L, and N are midpoints of the sides. Okay, so those are midpoints, so therefore those segments that connect them are called mid-segments. This is clearly another 5.1 question. So the next thing it tells us, if JH, so JH is 9, so this is going to be 9, HN is here, that is 7, and LM is here, that is 8. What is the perimeter of JLN? Okay, so good question. Let's see if we can work this out. Okay, I'm going to change my color to red for a second so you can see it clearer. And maybe I'll try to make this a little bit bigger. And there we are. We're successful with that. Alright, now, before I try to answer what is the perimeter of the inside triangle, I'm going to mark some more features. So, if JL is parallel to HM, then it's half the length. Well, HN is half the length of HM, so therefore I can put 3 little hash marks here and say that that's the same as HN, which was 7. So I'm going to mark this piece as a 7. Now I'm going to look at JN. JN is half the length of KM, so therefore it's equal to LM, and LM is 8, and therefore JN is also 8 because it is the same length, so I can put 1 little hash mark. So let me just go back and make sure it looks like an 8. Okay, this is an 8, and it has 1 hash mark. Okay, last one, LN is parallel to KH, and therefore it is half the length of KH. Well, JH is half the length of KH, and therefore I can put 2 little hash marks here, and that's a 9. So in order to get the perimeter, I'm going to add the 3 inside pieces together, and that's going to be 7 plus 8 plus 9. And 7 plus 8 plus 9 is 24. And that's the best answer. So that reinforces the fact that you can determine segment lengths given sufficient information from mid-segments. So that ends our 5.1 review. Make sure you understand this before you come in to take the quiz. Okay, we're going to go to the next page, and that'll start some 5-2 material. All right, in question number 3, it asks us to find the length of AB. So AB is one of the legs of the triangle. So I need to figure out what's going on in this triangle. And what I see is that BD is coming down, and it is a perpendicular bisector of AC. Okay, so it's doing two things. One of them is, whoops, let me just go back. One thing that it's doing is making the perpendicular, okay, that means it's a right angle, and the second thing it's doing is being a bisector. So that makes BD a perpendicular bisector. When I have a point like B on a perpendicular bisector, and the perpendicular bisector is this right here, this BD, what happens is, since the perpendicular bisector is bisecting this segment AC, any points that lie on the perpendicular bisector, that point is B, will be equidistant from A. So that means this leg equals this leg, because a point on the perpendicular bisector is the same distance from both sides of the segment that was bisected. So that makes AB will always equal BC when B lies on the perpendicular bisector of AC. All right, knowing that theory allows us to set AB, which is 2x, equal to 5x minus 6. And two-step problem, I would probably add 6, done, add 6, subtract 2x, done, subtract 2x. So I get 6 equals 3x, divide by 3, divide by 3, I get 2 equals x. Now, I am not done because they have not asked me for the x value. They've asked me for the length of AB. So here's AB, 2x. So I'm going to take my x of 2, plug it in, plug the 2 in, you get AB equals 4. And that's how you do that problem. So let's do the next problem on the next page. All right, in this question, what they're doing is they still want AB. So AB is what we're looking for. Okay, we need AB. And they want the length of it. So that's my question. I see where it is. So even though the triangle is turned a little bit sideways, so it's about 90 degrees to the right of where the previous triangle was positioned, I still have the same things going on. I see that BD, so this segment right here, is acting like a perpendicular bisector for segment AC, and I know that because this segment is equal to that segment, therefore that's a bisector, and I get a right angle. That's the perpendicular part. So when a line or ray BD came down the triangle and split AC in half, it also created a right angle, and therefore I have a perpendicular bisector. Point B is lying on that perpendicular bisector. Because B is lying on the perpendicular bisector of AC, B is equidistant from C and A. That makes this an isosceles triangle and allows me to set AB, which is 3x plus 8, equal to BC, which is 7x minus 16. So we're going to see what this equals. I subtract 3x, subtract 3x. I have 4x on the right. I add 16. I add 16. That gives me 24. So 24 equals 4x. So if I divide by 4, that gives me x equals 6. All right, now they have not asked me what x is. So if I stop there, I'm not going to get this question correct. So I need to take my x of 6, find my AB, and it's right here, and plug in the 6 right here for the x. So AB is going to equal 3 times 6 plus 8. So 3 times 6 is 18. 18 plus 8 more gives me 26. So my answer is that AB equals 26. Now, if you want to be smart about this, you should also plug the 6 into the 7x minus 16. That gives me 42 minus 16, which does equal 26. So that makes sense because I have an equilateral triangle. If I did not get 26 for an answer for BC, then I would think that something is incorrect about either my reasoning or my math, and I would go back and check it. Okay, we're going to do problems 5 and 6 on the next pages. Okay, now question 5 and 6 are figures, and above the figure it says, tell whether the information on the diagram allows you to conclude that C is on the perpendicular bisector of AB. All right, if I see I have an isosceles triangle, and I know that because I have equal sides, equal legs, so that means that this point C must lie on an unseen perpendicular bisector that would be doing this. The reason why I know that is if it is on a perpendicular bisector, then you get the isosceles triangle. And since we already have the isosceles triangle, point C must be on this unseen perpendicular bisector. So I would say yes. And it's yes because AC equals CB, which is the result of having C be on the perpendicular bisector. Okay, we're going to look at the number 6 on the next page. Okay, number 6 is a little bit trickier. I want to know, do I have enough information to conclude that C is on the perpendicular bisector of segment BA? And the answer is no. I don't know that. I know it's on the bisector, so bisector, I can say, yep, it's on the bisector, and that's because I see that that segment's been bisected. So segment AB is bisected by this bisector that's coming down, but because I don't have a right angle here, so I don't have a right angle written there, so it's not there. I can't assume it's there. So that's missing. What else is missing? If that was on a perpendicular bisector, wouldn't I have this marked as being equal? Then I would know. So let's say they didn't give us the right angle, but they did give us these markings and these markings. If I had those sets of markings, I could say yes, it must be on the perpendicular bisector. But look what I have. So let's go back. I only have one thing, and the one thing I have is a bisector result, not a perpendicular bisector result. So therefore I would say no. I don't have enough information to assume that point C is on the perpendicular bisector of AB. So that's no, and you would have to write a statement on your review explaining why it's a no. Okay, so far we've talked about the isosceles triangle that gets formed through the action of the perpendicular bisector. And we talked about 5.1. The last question in this review talks about the other thing that happens when you have the perpendicular bisectors inside the triangle, or not even inside the triangle, when you take perpendicular bisectors of each side of the triangle and look where they intersect. So we will do that question on the next page. All right, this is a very important concept to understand. And to illustrate it, I'm going to annotate my triangle with the information that's being provided in the diagram. So it says in the diagram, the perpendicular bisectors of triangle ABC meet at point G. Okay, so here they're meeting, and that meeting's happening right here at point G. Now, in class today, we talked about the fact that in an acute triangle, the perpendicular bisectors meet or intersect inside the triangle. That is the case here. So, could you go ahead and annotate your triangle with the information that's being provided? You want to stop the video and you do your annotating and then come back and see if it matches mine. Okay, so I'm going to start annotating now. Okay, the first thing I'm seeing is that I have perpendicular bisectors and they are the dashed lines. I'm going to make that more clear by going ahead and putting the right triangles right there. I may try to make my point of intersection a little smaller if at all possible. Okay, so it's kind of there, so that I could then indicate I have a right angle in here as well. It's just a little bit too small for me to do it. Unless, okay, so I can make it a little bit bigger. So let me try this. I will put a little box right there, because that's another right triangle. Okay, the next thing I have is the bisector result. So if this point BE was 15 and the segment's been bisected, then I know that EC is also 15. Okay, if the point AF is 24 and I know that AC has been bisected, then FC is also 24. If the segment BA has been bisected, which I know it has from what is written above, and AD is 20, then since it's been bisected, DB is also 20. Okay, I'm going to change color now, and let's talk about what happens when you draw a line, and it's the dark lines, from the G, which is the intersection of your three perpendicular bisectors. Draw your line from G all the way out to the angle. Draw your line from G to angle C, which is the vertex. Draw your line from G to angle A, which is another vertex. Those green lines will all be the same length. And what length will that be? That will be 25. So this is 25, and this is 25. Okay, let me make this a little bit smaller. And now, only now, after I've done all this illustrating, will I, let me just make this look better, will I actually start answering questions. The reason why I like you to wait to answer your questions until you've illustrated your figure is so that you are thinking through this process one time. And that one thought allows you to put all these numbers in place. If you wait and try to answer all the questions without illustrating, you are going to have to think this problem through the same number of times as there are questions. So I'd rather have you just work it through by first annotating and then answering questions. All right, so look at the question now. Find AG. Okay, AG is from angle A to the center to the point where the bisectors intersect. That is 25 because that's a green line. So AG is 25. Next, find BD. BD is the outside of the triangle. It's a segment that was bisected, and I know that that value is going to be 20 because it's right there. So far I have these two I've used. Okay, CF. Okay, CF is the segment that's been bisected. Because it's been bisected, AF equals FC, and therefore FC will be 24. Let me erase that last one. 24, and I'm going to check that off. Okay, BG. BG goes from a vertex to the point where the bisectors intersect, which is called the circumcenter, by the way, and that's going to be 25. So BG is 25. Do you see how I'm not thinking things through right now? I'm just reading off my values. It's much easier for you to do it this way. Okay, look at CE. CE has been bisected, so BC is bisected into two pieces that are equal in length, and since BE is 15, I knew that EC was 15, so CE or EC, no matter how you say it, will be 15. Okay, the last one that they're asking us about is AC. Now don't get fooled here. AC is the complete length. So if AF is 24 and FC is 24, then AC has to be 24 plus 24, or 48. And we're done with the review. So please go back and make sure you understand these concepts and that you can get these same answers without having to listen to me. Okay, just filling in the answers doesn't mean that you've studied for the assessment. You now have material that you've reviewed, which you can then study. So that's the strategy. So good luck. I hope this was helpful.